Okay, let's get started. So, raise your hand if you hate Flash. I don't particularly hate Flash. I think it's been a pretty useful technology for a pretty long time, but I think there's been, ever since the iPad came out in 2011, Flash was, reported dead multiple times. And, if you looked at HTML5 as it existed back then, it was useful in a very limited way. I mean, you could transmit a single file to multiple and desktop devices, but there wasn't any adaptive streaming. There wasn't any DRM. There wasn't any live streaming. There wasn't any true streaming. It was all progressive download. So the HTML5 hype was very, very, very hype until very recently. So we're seeing a few changes in the HTML spec. We're seeing technologies like the media source extensions and encrypted media extensions come out. More importantly, we're seeing players from innovative companies that are going to enable us to finally make the change from Flash-based playback with DRM, adaptive live, all that stuff, to completely HTML5-based playback. And the three companies that we have up here are BitMove, Incast Labs, and OpenTele. They came from very long distances to tell you about their technologies. The format today, it's not going to be a show and tell as much as it's going to be, here's what we did for a company. So the prerequisite for a company to appear up here with us today was they had to have a customer willing to talk about what they did and how they did it. So you're going to hear about actual companies, and they're pretty big companies, who are using HTML5-based playback technologies today. And we've only got a short period of time. We can run over a little bit, but I'm going to shut up at this point because that's all I really have to say. And then we're going to present in this order. First, Stefan Lederer from BitMove, and then Tobias Patella from Incast Labs, and finish up with Peter Jan Spielmans from OpenTele. And I'm hoping, they know they've got 10 minutes each or 8 minutes each, and I'm hoping we'll have time at the end for questions. We're butting up against the lunch session, so anybody who wants to stay over, I'm sure these gentlemen will stay over and take your questions as long as you want. So, Stefan, let me get your presentation up here. And
yeah, welcome. I'm Stefan Lederer, co-founder of BitMove, and we are focused on adaptive bitrate streaming, mainly with MPEG-Dash. That's our main focus, and there we have our expertise. But we also do HLS streaming as simply necessary today, considering the Apple and iOS ecosystem. We're based in Klagenfurt in Austria, and also have a US office for the US market. And we're a pretty young company, founded in 2012. Yes. We focus on the whole end-to-end chain, so we can generate MPEG-Dash HLS content with our cloud-based transcoding solution, which is currently the fastest transcoding solution on the market. Feel free and try it out. But today I will talk about our MPEG-Dash players called BitDash, and about the customer which is using it, Flimet. That's an Austrian, German-speaking type of Netflix. It's comparable to them, and yeah, let's go into detail. Our secret sauce is basically that we participated in the MPEG-Dash standardization since the beginning. We did the official reference implementation of the MPEG-Dash standard libdash, for example, and the first MPEG-Dash player back in 2011, which was a VLC implementation. So we really know what we are doing, and we have also invested a lot of time in better adaptation processes and better adaptation logics. And that's the reason why our player is really, really acting well with fast startup delay and seeking behavior and a better average quality in the end. And the big focus is also common encryption and the HTML5 encrypted media extensions, as this is the future of DRM on the web in our point of view. But let's go into the case study. I want to talk about Flimet. It's a VOD provider. It's owned by the public broadcaster of Austria. They previously used RTMP streaming with Flash and have been quite annoyed by that and also their users, and wanted to have something which is comparable to the quality and to the technology which is used by Netflix and all the other providers. So there's a huge pressure on this type of companies on the market. And we enable that with HTML5, EME, MSE, and our players featuring MPEG-Dash. This customer supports desktop, mobile, mobile apps, mobile web, and smart TV platforms just with these two formats, MPEG-Dash and HLS today. The project was started in November and went live in March 2015. What we do here as a special thing on the player side as well is multiple audio languages, multiple subtitle captions, and so on. So that's really cool to have in HTML5 using WebVTT, for example. And that's straightforward to use and working out of the box. That's really, really convenient. And you don't need any plugins for that. And you're also ready to go for the future. So compare, for example, 4K playback in HTML5 versus in Flash. In HTML5, that's no problem at all. And with Flash, you are having serious troubles there. On the solution itself, we focus on MPEG-Dash, as mentioned, as a first format, and using the HTML5 media source extensions. If there's no media source extensions available, we fall back to our MPEG-Dash implementation in Flash, so we can serve any web environment with MPEG-Dash today. And on mobile devices, on iOS, we fall back to HLS, as this is mandatory, of course, on that platform. Hopefully that changes in the future. We already see the HTML5 MSE support in Safari for desktop today, so maybe that happens also in the future for mobile devices. On iOS, you have to go for the HLS way. On Android, you can go for the Dash way, either in the browser using Chrome and the media source extensions, or going for the EXO player from Google, which is a great piece of software. And on the smart TV, of course, you can use HLS on older devices and Dash on newer ones. On the encoding side, we used our transcoding platform. We went up to 4.5 megabit per second for 1080p, ranging from 1080p to 140p for mobile devices in terms of quality renditions. And we used MPEG-Dash and HLS and used Amazon's AWS infrastructure on the origin side and different CDNs for the distribution side. In the different platforms, to really take it to the details, on Chrome you can go today with HTML5 MSE, that's the best platform to go for. You use MPEG-Dash, you can use Whiteware Modular on the DRM side, that's straightforward. Same applies for Internet Explorer 8.1, where we also have the HTML5 MSE implementation ready to go there. You can use MPEG-Dash and PlayReady in this platform, and with a multi-DRM provider in the background and common encryption, that's not as bad as it sounds at the beginning. Internet Explorer 7 is lagging behind, unfortunately. It could be nice to have an update for them as well, but at today's situation we have to use BitDash using our Flash implementation, or going for a Silverlight fallback is also possible, and then go for either ClearKey or PlayReady using the Silverlight fallback. On Firefox, we are currently about to switch to HTML5 MSE. The update of Firefox enabling the MSE is just about to be released. Should be already in the last version, but they didn't manage to do it, so it's in the next release now. And the EME is coming in the version after, with two CDMs inside, Adobe and Marlin, and again with common encryption. That's pretty straightforward. Safari can also support MPEG-Dash natively, Android on the web with Chrome as well. And here it's definitely to go for MPEG-Dash because the HLS implementation on Android is not very usable. And as said, on Android the EXO player is great, and on iOS you have to use HLS as fallback, which comes together with problems on the DRM side, as most of you probably know. Yes, the project is online today. You can log in on the website and see it by your own. there are a lot of trailers also for free, so give it a try and check also startup delay and average streaming quality and so on. So you will see a difference, and normally it's better than the quality you get with Netflix. On the encoding side, maybe some last details. With MPEG-Dash and HLS, you can really reduce the complexity of your deployment. Just 2 formats with 2 manifests to reach all devices from desktop to mobile to smart TVs. And that's the best thing you can do. And you can restrict upper and lower boundaries of the qualities, for example, on mobile devices, just by configuring the player in the proper way, like limiting the maximum quality of smartphones to reduce battery consumption and so on. So that's really easy for them, and they reduce the complexity of their formats tremendously by this approach, and also storage costs and caching efficiency on the CDN. Okay, that was it. Thanks.
Okay, thank you. Let me say, we will have these presentations up on the streaming media site probably in the next couple of days. If you check my site, which is streaminglearningcenter.com, I'll have it up there by the end of today. So you'll be able to download the PDFs. I know you probably want to take your pictures anyway, but they'll be available. Streaming Learning Center by the end of the day today, streaming media website probably in the next couple of days. Okay, Stefan, thanks very much. Now we're going to hear from Tobias Patella from CAST Labs.
Yes, thank you very much. My name is Tobias from CAST Labs. And just to give you a bit of a background, what we do at CAST Labs is to enable our customers to offer the delivery of DRM-protected premium video content on all kinds of devices. So what we do is cover all aspects, starting with the content creation side, with packaging and transcoding. Then we do offer a multi-DRM cloud-based service to enable the DRM services. And then we offer, on the player side, various SDKs to cover all platforms, desktop, mobile devices, and large screen devices as well. And today, should I go over, or
I just want you.
Do you want to?
You want to sit here, or do you?
Sure, maybe that might be easier.
Okay. Why don't you? You can get my mic. So take yours off.
Okay, but hello? Can you hear me? All right. Today I would like to focus on our product for the desktop, which we call Dash Everywhere, and that enables our customers to offer the playback of Dash content in the browser across all platforms on all devices. So no matter if you are, no matter which browser you're using, the promise is that you only have to implement a single player to enable playback, in the best case without the use of any plugin. So what we did is to develop a player that can handle Dash content to be future-proof, but because most of our customers also have legacy content, for example, with a lot of smooth streaming content, so we wanted to enable that for them as well by giving them a product where they only need to implement a single player that can handle all the various formats on each and every device out there, no matter if it's smooth streaming content or MPEG-Dash content or even HLS, and we do support that across all the browsers. And to enable that, and our sort of like secret sauce here is that we were able to decouple the streaming protocol from the DRM being used. So usually when people had smooth streaming content, they had to use it with PlayReady as DRM on the back end. And this is no longer the case. What we did is to completely decouple it so we can play back smooth streaming content in Google Chrome using Widevine Modular as DRM. And by doing that, we eliminated the need for PlayReady at all. But of course, there are also still end users that don't have Chrome installed. So in that case, we offer fallback to Flash or Silverlight to ensure that the content can be played on any device and on any browser. And now I would like to get into the details of our case study, which is about HBO Europe. And just to give you a bit of a background, HBO Europe is the technical implementer for various HBO divisions around the world. So they develop the player technology for HBO Go, which is a desktop product. And they developed that for HBO Asia, HBO Latin America, and HBO Europe itself. And the situation they were facing is that they have a huge content library with smooth streaming content, and they have a lot of premium features like multiple language tracks and multiple subtitle tracks. And of course, they could just retranscode everything into a future-proof format like Dash, but that cannot happen overnight. That would be too risky of a move. So what they did together with us is to implement the Dash everywhere on the player side. And that means they did not have to change anything with their content. So they could just use the existing content library, which is all smooth streaming, original smooth streaming format, and which was used previously with Play Ready. And by implementing our player, they did not have to change anything on the back end, but they could just replace the player and then play back that smooth streaming content on the browser in Chrome using HTML5 and the encrypted media extensions together with WideRun Modular as DRM. And by that, they solved the issue of the Chrome Silverlight application, because they had the situation that a couple of weeks back, Chrome disabled the usage of other plugins in their browser, so their old product, which was based on Silverlight, simply stopped working. But now moving to HTML5, they had a way to solve that issue. So now if you go to the HBO Europe website and you want to watch a DRM protected video there, you can do that in Chrome without the usage of any kind of plugin at all. And just to give you a bit of an overview about the implementation details, you can see how we, what I've mentioned earlier, how we were able to decouple the streaming protocol from the DRM. So the content is always original smooth streaming content, which was originally packaged for Play Ready. And with our solution, if you play it in Chrome or IE11 on Windows 8.1 and Firefox soon to come, and hopefully Safari as well, you can play it back without the usage of any plugins at all, using HTML5 and DRM in case of Chrome, WideRun Modular. And then on older devices, on older browsers like currently Firefox or older IE versions, it would fall back to the Silverlight solution using Play Ready, or if Silverlight is not installed, they could also use Flash together with Adobe Access. So again, it's a completely decoupling of the streaming protocol and the DRM system. And the most amazing thing actually is that the whole process didn't take a lot of time. It was a very smooth process for them. So they started looking into it second half of February this year. And just a few weeks back, late April, they actually went live with their production site in Europe and rolled it out over a couple of European countries. If you go to HBO Europe, one of the websites there today, you will see the HTML5 base playback today in the browser. And again, it's very important they did not, because there was a big requirement from their side, they did not change anything on the content side at all. It's all done on the player side using HTML5 and the encrypted media extensions. And with that being said, I would like to thank you and happy to answer any questions.
Test. Yeah, okay. Okay, so I'm from OpenTele. We were actually a company founded in 2012. And what we started doing in 2012 was we were providing streaming services to content publishers. But what we noticed very soon was that it's very difficult to publish the content to all the different platforms. Which is why we developed a product called TLPlayer, which is a pure HTML5-based feed media player, which allows you to do adaptive HLS streams on all the different platforms without plugins. And when I say without plugins, I really mean without plugins. We don't even have a Flash or a Silverlight fallback. And we do actually also support all the different platforms. You can test it on our website. Feel free. That should not be a problem. So my case actually is about VRT. VRT is actually the Flemish public broadcaster. Flanders, for those of you unfamiliar with Belgian politics, it's actually the Dutch-speaking part of Belgium. And they distribute their content across 3 different TV channels, and they have 5 different radio stations. But what they also have is a very strong online presence. They have brands such as The Redactie, which is their news outlet, where you can watch live and on-demand news broadcasts. But they also have Sporza, for example, where they do a lot of live streaming of sports matches, but you can also catch up later or watch replays on demand. So what are they doing and what were they doing before we actually met them? They were using actually 4 methods, which are pretty common when you're streaming these days. The first approach that they're using is actually they're using plugins, which was the Flash-based approach in order to do HLS, adaptive streaming, in web browsers. But of course, as mentioned earlier, this approach doesn't even work on mobile devices, and it always requires your user to have the plugin installed. Whether if it's Flash or if it's Silverlight, you will always need the plugin to be available on the device of your user. So the secondary approach that they're using, especially to target the mobile devices, is they're developing custom apps for Android and for iOS. Of course, this is also a very expensive process because you have to develop and maintain all the different apps. And it doesn't even allow you to do anything else in the mobile browsers. So for the mobile browsers, they were actually doing progressive downloads of MP4. But the downside is that it's not adaptive streaming, and it doesn't allow you to do live. So your users aren't able to access all the content that they want, which is still a problem, which is why they're using a 4th approach as well. And that is actually streaming in multiple different formats. But, well, it's an additional cost, bandwidth, encoding, storage, in order to produce all of these streams. And with some of these streams, you're actually reducing your user experience because, well, some of these protocols are opening in separate apps, which is, of course, a big change instead of playing them in your website. And if we look at those 4 approaches, what we are actually seeing is that they're very expensive, they have a high complexity, and, well, they reduce your user experience. And now the big question is, try to imagine what it would mean for a content publisher if you would be able to stream to all the different platforms and devices using just a single player and using just a single streaming protocol. That's actually what we're doing with TheoPlayer. So TheoPlayer allows you to stream to all the different platforms using a single player and using a single streaming protocol, which is HLS. And as mentioned earlier here, there are methods doing this using, for example, media source extensions, but TheoPlayer doesn't even need media source extensions. We can work in browsers who don't have support for media source extensions, which means that we can go back all the way to all the browsers where other players require plugins in order to function. And another question, of course, that we often get is, what can we do to protect our content? So with TheoPlayer, what we are actually offering is we have implemented the HLS standard AES 128 content protection. And we've done it in HTML5, so it can be used on all the different platforms as well. And of course, doing DRM in pure HTML5 across all the different platforms, today that's still a challenge when you want to do it in HTML5. But with TheoPlayer's AES 128 content encryption, you have a uniform approach to stream to all the different platforms in HTML5. And well, TheoPlayer at this point, I think we've tested it with over 150 different publishers. And one of them, of course, was the VRT. So within our tests with VRT, what we actually have proven there in our tests is that with TheoPlayer, they can reduce the complexity of their streaming infrastructure, and they can reach more platforms than they can reach today using just a single player. And that is why at this moment we are actually doing an integration with them. And we have selected some platforms as a first stage to roll out. For example, Windows Phone. At this moment, they're unable to stream to Windows Phone. But with TheoPlayer and with the integration that we've done, they are actually able to reach Windows Phone and stream live content adaptively in the browser without any problem. And well, what are the next steps? The integration should be finished by the start of the next TV season, so in September. And after that, we will be evaluating and doing a rollout to all the other platforms as well. But I think what's really important to remember here is that you can actually remove the dependencies from plugins totally from all the different platforms. And you can even do it using a single streaming protocol, which dramatically simplifies your infrastructure. So thank you very much. And that was it.
OK, so now we'll take questions. And I'm going to the extent possible, make sure they each get a question kind of in order. So who's got a first question? I guess I presumed we'd have questions.
Is the TheoPlayer based on open source, or is it yours?
Let me repeat. Yeah. Is the TheoPlayer based on open source, or is it proprietary?
Well, it is actually proprietary. We have actually filed patents in order to protect the technology that we are using also.
Talk a little bit about how it works with other platforms besides browsers?
Which company? Any of them?
Any of them.
OK, why don't we, Stefan, let's start with you. So how do you work with like smart TVs and OTT and?
Yeah, smart TVs support MPEG-Dash, at least the current ones. So that's working out of the box. Especially in Europe, HBB TV 1.5 is supporting MPEG-Dash as only adaptive streaming format, so you have to go this direction anyway. Older smart TVs get HLS because, yeah, they just support HLS. Chromecast is also a quite popular device currently with our customer projects, so that runs out of the box with the MPEG-Dash content to serve it to the devices using the player is also directly from web browsers, from mobile web browsers, from apps, whatever. On Android, we use a SAT EXO player, which is really, really nice for live as well as for on-demand content. Also implementing wide-band modular, we're using common encryption. Also supporting HLS, which is also quite nice because the standard HLS support in Android is really, really poor. And on iOS, we use the standard HLS client.
Tobias?
Yeah, what we do is actually to support all the protocols, smooth streaming, HLS, and Dash across all platforms. So for mobile devices on Android and iOS, we do have native SDKs that do support Dash and smooth streaming plus HLS using DRM on both devices, or on both platforms, iOS and Android. And for smart TVs, it's pretty much true what Stefan just said. And it's the same, our Dash Everywhere product has built-in Chromecast receiver functionality, so you can just have it run on the Chromecast and you're all set implementing it, playing back DRM protected content on Chromecast as well.
And well, I'm gonna fall in repetition. So everything TheoPlayer is pure HTML5. So even in apps, if you would want to use it in an app, you can just use it in a web view and then it will work. So you can, with TheoPlayer, you can really use one player and integrate it with it. So smart TVs, they have HTML5 support, so it works there. We have set-top boxes. We have consoles such as the Xbox One or PlayStation. We have tested with a very wide range of different platforms and different protocols and different browsers. And yeah, we haven't met a problem to this point.
Quick question regarding the H5-based player versus the, let's say, Android player, XO player. What's the pros and cons of using, let's say, the H5-based using WebView within the apps versus using a quote-unquote proper XO player?
Did you ask about the cost or the
Technology, efficiency, and all of that, user experience around.
Can you repeat the question? Because
Yes.
I don't understand.
So the question was whether it's better or more efficient to go for the HTML5 web view in apps or using native players like the EXO player. That's a quite frequent question. It heavily depends on the app and on the guys who in the end develop it. You can do everything with the web view in the browser. However, some Samsung devices, for example, don't use Chrome as standard browser. They use the stock browser as standard browser. So there you don't have the HTML5 or the MSE support. So you would have to fall back to the standard HLS support, which is one of the negative things using the web view in Android. EXO player basically works from version 4.1, I think, and that's straightforward. It's easy to use, and the community is great. So in the end, I cannot find good arguments against EXO player. So we use it as in our customer projects for live and on-demand streaming. The adaptation logic is quite good, but you can also hook into your own adaptation logics, like we do usually. And that's great to have. So Flimit uses the EXO player for on-demand content. Another customer from us, Krone Hit TV, is using it for live content. You can download the apps and play around with it. And I think it's a good solution.
What about TV boxes, Android TV boxes? Can you use that?
Yes.
Use that player as well?
Yeah.
Just to pick in, by the way, but you don't really need to use the native HLS playback on Android. You can also use your own HLS playback, even in a web view, for example, with Theo Player.
Tobias, anything to add?
Sure, yeah, I would like to jump in there as well, because in our experience, the browser-based HTML5 playback on Android is not really that good performance-wise. So we've seen a lot of customers that tried it, and they can actually use our Dash Everywhere product. It runs on mobile devices as well, and on modern devices like Galaxy Note, which are very powerful, it performs well. But if you look at older devices, actually it starts to slow down, and the playback experience is not really that well for most end users. And if you take a look at the EXO player, the issue there is that it only works for DRM protected content on Android 4.4 and newer devices, which means if you're going to go with EXO player, you are leaving a huge customer base behind and cannot use it. This is why we actually offer our own native Android SDK, which works on all Android devices, starting with Android 4.0 and higher to enable DRM playback. And also, if you start looking into premium features like multiple channel audio, surround sound, or DTS Headphone X, for example, which we just implemented for one of our customers in Silent, which is really a premium feature and a great selling point for them to enable that headphone virtualization thing. And if you want to start using those features, you cannot use the stock EXO player. There's no chance of implementing it.
What's the best streaming protocol for live streaming?
The question is, what's the best streaming protocol for live streaming? I can understand that one.
That is a great question. And which device or which platform are you talking about? Because I guess that really depends if you're like talking about Android, iOS, or desktop devices, smart TVs. So
Let's start with iOS and Android.
well, I'm not gonna go here and say this is the best streaming protocol.
One is better on the other platform.
I mean, you can use Dash for live streaming as well, and we do actually have customers that use Dash for live streaming. So we have a couple of TV operators in Europe that use Dash for live streaming. Some of them also use smooth streaming. So I guess it really depends. Yeah.
From our point of view, of course, we are the Dash addicted ones. We prefer Dash for live streaming because with the MPD and the manifest organization, using segment timeline, for example, you can really provide focused MPDs to speed up startup delay, to reduce end-to-end delay, and that are benefits we see here. We also have custom modifications for the manifests, including live edge number, for example, which is one of our patented solutions, which further get this end-to-end delay down. And the degrees of freedom using HLS are a lot less than these degrees of freedom you have with MPEG-Dash. And that's the reason why we prefer MPEG-Dash over HLS. And as said, if you want to try it out, for example, on Android, download the Krone Hit TV app. There is a live stream using MPEG-Dash, using ExoPlayer in there. I think that's the best startup delay you will see. Unfortunately, it's distributed from Europe, so here in the US, the connectivity is maybe not the best, but still, it works.
Yeah, and maybe if I may add one more thing, just to make it clear, because usually our customers, most of them, they want to offer studio-grade content. And if you deal with studio content like movies, you cannot get away with basic HLS encryption. So you need a DRM, which rules out to use HLS. So you need to use a different protocol, which means either MPEG-Dash or smooth streaming. But you cannot get away, and you cannot stream studio content on devices using no DRM and just AES encryption. So that rules out HLS.
Well, I don't totally agree, of course, but I think that there is no best streaming protocol for live. I think what you always have to look at is what you're trying to achieve. If you're trying to go with low latency, I would even say, well, go back to RTSP, but that's currently the best solution for that. But I think all the HTTP adaptive streaming protocols, they're more or less the same for live. So which one you use, eventually it will come down to what your backend infrastructure allows you to do and what the player allows you to do.
There was a question.
I think this question is for Tobias. I think if I heard correctly, for HBO, that's the only customer pipeline that's using actual DRM in the cases provided. So
not the only one, yeah.
It sounded like the HBO Europe didn't have to do any. They were using existing transcoded content. In that timeline, it didn't sound like they retranscoded content. But did they have to transmux to use common encryption? I mean, can you talk specifically about the use of common encryption, not just falling back to existing encryption that was, or DRM that was in place?
Let me repeat this. So the question is, you understand HBO didn't have to transcode, but did they have to transmux to use common encryption with their existing media files?
Okay, thank you. That is a great question. And short answer, no. Longer answer, they did not have to touch the content at all. So there was no transmuxing, repackaging, or re-encoding. And the background is that actually the encryption used for smooth streaming and Play Ready is very close to common encryption. And then on the player side, we add our magic sauce and transform that content to make it sort of like Dash compatible, which enables us to play it back using common encryption and any DRM. It can be, again, for Chrome, it's wideband modular. For Firefox, it's going to be Adobe Access. And for Safari, it's going to be Apple FairPlay. And you can completely decouple that. So again, the content is untouched. You have the content as it is, your smooth streaming, Play Ready, encrypted content sort of like, and you can still use it because they, of course, they still have like legacy devices like smart TVs, for example, or maybe an Xbox that requires them to use the original smooth streaming content with Play Ready. And that is still completely, you can still keep using your existing content with any legacy devices, and then without touching the content, using it with HTML5 from the browser.
Old wideband encrypted content, or secure media, or any other DRMs?
For wideband encrypted content, you mean wideband classic content? Yeah. You cannot do that on the fly, but we do actually have a cloud-based solution that enables you to just repackage wideband classic content into Dash content. So there's no re-encoding, but you need to repackage that. That cannot be done on the client side.
Yeah, that's an approach we also did with a customer in Indonesia, Orange TV, which implemented common encryption using Dash. And there you can also do it for using an origin server, which is capable to do on-the-fly transmultiplexing to Dash, to smooth streaming, to whatever. For example, using unified streaming or solutions like that.
Any other questions? I've got a couple. What have your customers said about performance and I guess customer satisfaction incident to the switching from Flash to HTML5 based playback? Peter, why don't you start?
Well, with us, it was all positive, mainly because on most of the platforms that we're supporting now with 3RT is that, well, they weren't able to provide proper support in the past. So their users are actually very happy with the support that we're providing. So yeah, we haven't heard any complaints there.
Our customers have been quite positive. So the flexibility you have with Dash and to some degree also with HLS in HTML5 are great. So the flexibility of, for example, late binding the content, so decoupling audio, video, caption tracks, for example, and downloading them on demand when it is needed. So the user can switch between the stream, can switch between audio and video, between the different audio languages without a problem, and the video continues to play in the meantime. And you can store that also on the server side separately. So on the one hand side, you have a cost reduction due to the decoupling of audio, video, and captions. And on the consumer side, you have a really, really much better user experience by providing the ability to easily switch between languages and captions and so on. So that was one of the most positive feedbacks we got from customers. And a second one is definitely the possibilities to have in an own player. So if you go for the native HTML5 HLS support in Safari, for example, you have one adaptation logic which is there for everybody the same, and you cannot differentiate. So having a specialized player like the BitDash player from us, you can really focus on startup delay, on average streaming quality, on utilization of the bandwidth, for example. A typical HLS client of Safari usually has 50% bandwidth utilization. With our player, you utilize 95% of the available bandwidth, and without just switching the player, you end up in doubling the quality the user sees in the end. And that also is one of the most or the best selling positions for us, and you can do that easily in HTML5 by deploying the player, and yeah, that's something which is not that easy in Flash and so on. That's the reason why we focus on that.
Tobias, what are you hearing?
Yeah, it's similar for us actually, that the feedback we have received from our customers is very positive, and they basically love it for two reasons. First of all, it's very convenient for their end users, for the consumer, because their consumers don't have to deal with any plugins anymore, and we all know Safari, Flash, and Silverlight plugins. They can be pretty bad performance-wise, so their end users love it that they don't have to deal with those plugins anymore. And the second and maybe more important reason is for our customers, which the feedback has been so positive, is that they don't have to touch their content, and they can actually gradually make the transition from the existing legacy content over to a future-based solution like Dash. So they don't have to convert all their whole library overnight into a format like Dash. They can keep using the existing format and then gradually over time slowly make the transition to Dash. And those are the two major reasons why they really like it.
One of the cons of this knowledge is that you're removing logic with time. Are you doing anything to protect the code?
Yes.
So you're saying it's a negative that you're removing,
Negative.
removing.
All the logic, the code, it's in time.
Okay, so you're going from server side to client side. What's been the negative, or any negatives associated with that?
Well, even with Flash, it was already on the client side, so there isn't a big difference there. But well, of course, you have to take some measures in order to make sure that your code isn't, well, let's call it stolen. But yeah, especially for us, we're in pure JavaScript. JavaScript can be read by everybody, but we have pretty good obfuscation and encryption of our code to make sure that there is a very good layer of protection. But well, our main focus with the obfuscation was actually to optimize it and not really to protect it. But it was a very nice side effect that it's pretty good obfuscation.
Same applies for us. And if you have some really critical parts, you have to file patents anyway, like for example for our adaptation process or different other functionalities. And that's another layer of protection, but with the obfuscation in JavaScript, that really works very well and is definitely something which can be used today.
And one important thing to keep in mind is that the whole DRM part is not done within JavaScript. So the DRM part is implemented natively by the browser, and our player doesn't even have access to it. So the unencrypted content is never within the JavaScript world and never even accessible by the player. So our player only deals with the encrypted bytes, sort of like, moves them over to the native world, to the browser, and the browser then does the decryption. And this is all, and therefore, even if you hack all the JavaScript code, there's no chance you get access to the unencrypted content at any time. So it's highly secure and approved by all the Hollywood studios.
Anything else? Okay. Thank you for coming, and gentlemen, great job.